Hello team. Today's challenge is between two buckets where we're given two buckets of color. So there's color one, color two, it's RGB values. So an array of RGB, and down in here, this is actually black 000, and the amount that is in each of those buckets, right? And we need to use that information to mix it to a final color. So kind of interesting like that. That's not really how paint works, right? It's not additive, it is subtractive, but we're going to run with it, right? So over here, the first thing that I want to do is I want to make this so that I can send in any number of buckets, because why limit ourselves to two, right? If we just have two, then yeah, the math gets really easy and we can knock this out pretty quick. But as a bit of an interesting bit, we can go buckets, and now they can send in any number of buckets they want. Okay, so long as they meet the shape of a bucket, right, having a color and a fullness, we can do it. So the first thing that we need is the total fullness. The total fullness is going to be used for doing our averages, right? Because there are some here, like this is 50-50, that's 100, 80-20 is 100, 30-70 is 100, but here, 45-90, that's not 100, right? So we need to figure that out. And 29-54, I think that's what, 83, right? So definitely not 100, not 100. We can figure that out. And to do that, we need to know the total fullness so that we can run our averages, okay? So for that, we're going to go total fullness, just like this. And that is going to be our buckets dot reduce, right? So based on that, we're going to get the accumulator and the bucket, right? Usually that would be current. And in fact, we don't need the whole bucket. We just need the fullness, right? So in curly braces, we can go fullness, just pulling that out and using it. What are we doing? Well, it's going to be accumulator plus fullness, summing it up and doing it. We do need a zero here, right? With some of these summing functions, sometimes we can leave the zero off because it takes the full first value, but the first value is the whole bucket, right? So the whole bucket would be dropped in here, which would make a very big mess of all this, and that's not going to work. So you should probably, you definitely need the zero today, okay? From there, we can do this part, right? And this part is buckets. Now we're going to create a pipeline here, right? So we're going to reduce just like this. That's going to be accumulator. And again, I'm going to pull out color and fullness, right? We need both those for this one because we're going to run the numbers, right? This is where we get our final output, which is why we return directly, and we do it, okay? Now inside of here, I'm going to return that color, and I'm going to map over each value, okay? So we have the value and the index just like this, which means that inside of here, we can get our mix, right? You could just return directly, but there is a reason for me adding this extra variable. You'll see in a second, right? Const mix is going to be the accumulator index, which is something that we haven't talked about yet. Where is my initial value for this reduce? We'll talk about that coming back to that, but it's going to be accumulator index plus value times fullness, just like this, divided by total fullness. It's going to wrap and be messy, but that is okay. Okay. And then we return what? Well, we return the mix. Okay. What is our initial value? It is not here, but down here. Okay. Getting it in the reduce and not the map. It is an array of 0, 0, 0, right? If one of our colors is black, it's not going to add anything to this, and that's perfectly okay. But everything else should roll these numbers up. The problem is that now we have a bunch of floating numbers in here. We don't want floating numbers. We want integers. So we map one more time, okay? Sending in the color, doing the thing, and going math.round for C, which means now it works, okay? There's a small problem in here. Not really a problem, but a small thing that we can fix, and something that I want to call out, right? So technically two things, I guess. Who am I for accounting? But right here, I did this, right? I did this constant mix, and then I returned the mix. And I did that because what happens if we have a bunch of buckets or our colors mix in such a way that they are way higher than 255? Because RGB is values from 0 to 255, 256 different values, right? Well, if it's over that, it just defaults to white, at least the way that browsers work, right? So it clips at 255 and you get whatever the brightest color is for whichever RGB you're using. That's fine. Except that if somebody console logs the output from our function here, right? If they console log mix paint with all of our buckets, they're going to get a number that's like 1000, 1000, 1000. That is very much not an RGB value. That's just three really, really big numbers, right? So what we can do is we could, not like that. I want to wrap this, okay? And then I want to go math.min 255 or mix, whichever one is smaller. Doesn't change anything, but in terms of RGB values, it starts to get the job done, okay? So that's a little bit of a thing. It doesn't add anything to here, but for me, it's important to know, right? Because it's going to make future me's life easier when I have to debug something further down the line, okay? I sent this whole thing into a bit of a code review, and I discovered that I have too many loops going on here, right? And maybe you've already seen it. You were like, Dave, why did you add this final map? Why didn't you just get the rounding inside of here somehow? We absolutely can. We can't do it with this, right? If we try to do the rounding inside of here, then we will be rounding ahead of time, right? We'll be rounding each time we add a value to our accumulator, which could cause off by one errors, right? We don't want to do it that way. But what we can do is we can flip these two things. So we could do the map first and the reduce second, and then have all this math inside of the reduce instead of the map, at which point, yes, we can in fact do the rounding, right? So a little bit of interesting stuff, and we're going to do exactly that. So I'm going to grab this, bring it down. I'm going to flip around to get rid of our solve message. The total fullness stays the same, but this right here goes away, okay? In fact, I'm just going to go and delete it because I have the reference above. So there's really no point, okay? But we can return, okay? And what are we returning? Well, we're going to return 0, 1, 2, okay? I debated, right? This is actually RGB. That's kind of what we're going for here. So if it's easier for you, you can change this to RG, whoops, doing it right, G, come on, it's jumping around, B, just like this, N, B. Apparently I can't type that for the life of me, but RGB and then map, okay? Both are going to get you to the same place. You could use the 0, 1, 2, right? And use that directly as your value, or you can use RGB and use the index as your value because they're the same thing, right? It's kind of weird like that. But inside of here, because I am using RGB, I'm going to underscore this because I don't care about the value, but I definitely care about that index, okay? And that index is how I get all of the different all the different R's from my buckets, and then all the different G's and all the different B's. That's how I do that, okay? So inside of here, I'm going to do a thing, okay? And that thing is going to be the reduce. So const, I'm going to get buckets, sorry, not like that, const mix equals buckets dot reduce. Okay, so now we are iterating on the buckets, and each one of those is going to go through here and get those values. Okay, so I do all the buckets for R, all the buckets for G, all the buckets for B, right? A little bit of backwardsness, which is why this feels a little bit weird, but it does get rid of one of those loops, so it is worth exploring. Okay. The reduce, we have the reduce. We're going to do the accumulator. We always need the accumulator. And of course, color and fullness, just like this, sending both those into the callback. My starting value is 0, right? I mean, that's where we're at, because now we're dealing with just a single instance of these, which means that now we can do stuff, right? And what are we doing? Well, we are mixing. So return accumulator plus color I, right? So whatever the color I is for index, I have too many brackets. Let's fix that. Times fullness. Okay. This is going to give me the accumulation of all the R's, right? Which I then return because it maps out. Sorry, all the R's before the rounding, right? So, and then we send that, once we round that out, we send that back out as the R value, and then the G value, and then the B value. So hopefully that's making sense. Feels very wordy when I'm saying it out loud. But right here, we return mix, okay? But we need to go mix divided by total fullness, just like this. And then from there, we go wrap it up. Oh, don't do that. Come on, wrap it up. It's weird to me that the keyboard, the wrapping doesn't work in FreeCodeCamp. I'm not sure what's going on there, but only happens here for me. If it happens to you, or if it doesn't happen to you, let me know in the comments, because it's been bugging me. But we wrap this up and we go math.round, right? At which point the whole thing should work. It doesn't. What did I mix? What did I miss? Taking a quick look. We have the map. Oh, I used the wrong word here. Index. Okay. There it is. Okay. The hint was right there. So that's great. Again, if we really, really wanted to, we could wrap this up. So 255 and going over here and going in math.min. It doesn't matter for today. It still returns, but it gets a little bit cleaner. I'm not sure if it's entirely clean, right? Will me 6 months from now remember that I was dealing with RGB? That's where RGB will be more helpful than 012, right? I'll have to understand what 012 mean in relation to all this information. But RGB, along with the underscore and index, hopefully that's a little bit more clear. And if we really wanted to, right, we're dealing in RGB today, but what if we were dealing in CMYK, right? CMYK is 4 values, right? Well, with this current setup, we absolutely can do that. So instead of this, we could just leverage bucket 1. So bucket 0, right? That's the first bucket, dot color dot map. Okay, buckets. There it is. And the thing still works, but now it's actually pulling out the 3 values or the 4 values or however many values are in my color. That's what it's pulling out, and then it's trying to average that all. This line needs to change, right? So there's that, but it starts to become more flexible, right? Because now I theoretically could do this for both RGB and CMYK, or possibly others, right? Depending on what's what. So that's it. Like if we take a look at this, my first example, again, we still need the total fullness, and we use that to calculate our final average, right? We have to do this division here. Regardless of which solution we use, we have to use that. So we have to dig that out of the data, okay? And then I had a pipeline here where I used a reduce first, and then I mapped over and did that math, and then I had to add an extra map for rounding. Code review tells me that I could have simplified by reversing it. So instead of the reduce to the map, I did a map to a reduce. And by doing that, I was able to simplify things. It's a few lines less, not just one, but a few. And it, again, gets the job done, right? Again, not every solution, just hopefully 1 or 2 good solutions, right? I don't think performance-wise we're going to see a lot here because there's only 2 colors, right? So it's not like we're iterating on huge amounts of data, but it does work. So let me know in the comments. Did you like number 1, number 2? Did you go a different way? Like there are plenty of options. We could change this to for loops or something like that, right? If you tried something like that, let me know in the comments. Otherwise, for today, this has been Between Two Buckets, and I will see you tomorrow.